pilots get the glory, but they know who gets the credit for that opportunity. The engineers who design and maintain the world's most advanced aircraft. These days, cutting-edge AI technology helps keeps those planes in rotation as advanced software is used by the hardworking professionals on the front lines of maintenance. Learn more on this episode of Future Proof.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Yours truly, Eric Kavanaugh, is here. And today we're going to talk with Joe Early. He is a solutions director for the Innovation Lab at a company called MetroStar. And they're doing some really interesting work with maintenance on very expensive objects. This is, I believe, with the Air Force. And you're basically working with them using some of these large visual models as opposed to large language models to do what is essentially maintenance work and optimizing the maintenance work. But Joe, tell us a bit about, like, first of all, what is this technology and what are you working on? What are you trying to fix? What are you trying to help our military accomplish?
Yeah, so first, thank you so much for having us on today to talk
Yeah.
about Iris. It's definitely humbling to have this opportunity, and we appreciate the time. So, first, a problem statement, which is the Government Accountability Office, which is the big GAO investigators within the Department of Defense. They documented a persistent and widespread failure across military aviation. About 2 to 4 of 49 aircraft types meet mission-capable rate goals. So that means that aircraft have a sustainment problem, but also not only is it hard to get aircraft off the ground, but the cost of maintaining those aircraft on the ground is going up. And so this is being done on the backs of our maintainers. So our job here at MetroStar and what we're doing with Iris is to make the hard, essential work that's being done easier in context to what the maintainers need. So think about trying to fix something under your car in a cramped, dark space. But you can't really have anybody with you. You can't really see anything except for maybe a flashlight you're trying to hold awkwardly into that awkward space.
Right.
And then, and now imagine doing that inside of an aircraft with fuel and with hazardous conditions around you. So you're not just in the comfort under a car, right? That's one piece, but now you're actually inside of a tank with gas and fumes,
Hmm.
and it's dark, and you're trying to figure things out for how to do the work.
Wow.
It's hard to breathe. It smells like jet fuel. Fixes aren't always the easiest to do. Sometimes maintenance is actually done above your head where you can't even see it because the spaces are so cramped.
Wow.
So that leaves a lot of room for error. And so that's ultimately the problem that we're trying to solve there with Iris.
Well, years ago, I interviewed someone from Ford Motor Company. This is, gosh, it's got to be 7 or 8 years ago now. And they were getting all excited about this visual recognition technology for car parts, where you would just point your phone at the part and it would say, oh, this is X part or this is Y part, which is incredibly valuable information for being able to fix something and know what part you have to get and know what, what it connects to, all that kind of stuff. And that's kind of what you're talking about here, right? Is using visual to AI technology, and there's a specific word I'm forgetting to use, but basically it's an optical model that's designed to see what something is and then tell you what that something is. And that's what
That's right.
Iris is doing, right?
That's right. So maintenance has been done the same way for 50 plus years on aircraft. And so what Iris is doing, one, it's a camera that sits on top of the face mask for maintainers because this is done in a fuel
I
hazardous
see.
conditions.
I
It's
see.
actually a 3D printed connection to the mask. So there's no change to how the mask fits. There's only an adjustment to how that information is being shared outside of the tank. So what we're enabling them to do is now we have a camera that sits right on top of the mask. Next to the camera are two lights, and then with the maintainer around their neck is now comms. So
Hmm.
now you can talk,
Hmm.
you can share the video, and your hands are free. free hands with lights right there. Everything is
Mhm.
called Class 1 Div 1. So you can take light and camera and electronics into the tank without creating additional risk. And what that does is that's a wired connection that goes to a cart, an air cart, and a communication cable outside of the tank, connecting to a computer on the cart, which now allows us to have a data feed from inside of the tank to outside the tank. So now on a tablet outside, or even through conference call, we can bring as many people as we want inside the tank with the maintainer,
Oh, interesting.
and we can
That's very
connect
cool.
it to LLMs. There's things called tech orders, right? From your example with Ford. How do I know that I'm fixing the right thing in the right way? Well, you actually need documentation that is
Hmm.
explicitly stating, here's how we fix it. Now, what we're able to do is now you can have a pair that says, here's what you're seeing in the tank, and align that with the tech order that says, are you fixing the right thing in the right way? And now you're getting a live feed of the in facts around the fact that you're fixing the right thing in the right way. And then afterwards, instead of what maintainers do today, is they draw a picture of what they just worked on and they turn that over to the maintenance desk to say, here's what I just fixed. Now go QA it. Go make sure there's quality control around it. And what was happening, this just came out in Business Insider, which was one of the maintainers told the story of, oh, well, there's a puddle tomorrow. How do I know if you fixed the right thing? There's not
Hmm.
that log. There's just the hand-drawn picture of what you thought
Wow.
you just fixed.
Right, 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 right.
And so we're able to not only log the video, but we're also able to in tank communicate what's being done in the right way in order to validate and verify, meet some of those system engineering principles, what's being done.
Well, and also, these devices are heavily instrumented these days. So you're able to, I'm guessing, to pull all sorts of data from the tank, from its usage. It's an IoT solution, right? Internet of Things, where you've got sensors all around the tank. And you can, I mean, this has been going on in like the Air Force for a long, long time now. Predictive maintenance is new for many industries. It's not new for the Air Force. There was a guy I talked to 20 years ago who, when I was working for the Data Warehousing Institute, who said, yeah, this is what we do. We've got instruments on all these different parts of the engine, and then you monitor all that data, and you can predict based upon what's happening with this part, what's going to happen with that part. And so what they learned is, hey, when this rotor starts to act funky, we have to act quickly. Otherwise, this downstream part is going to break, and that's the expensive part. And that's kind of what you're talking about with predictive maintenance, right?
Actually, it's a more holistic data picture than that.
Hmm.
So zoom out and say, is the predictive maintenance work currently being done the whole picture of data needed to actually predict maintenance?
Hmm.
And the data that's collected off of the aircraft based on these conditions often come from the sensors,
Hmm.
which means that you're getting the engine readings, you're getting all these different consumption of parts, maybe from the supply chain upstream saying, if I ordered this part at this time, based on the wear and tear, I'm able to maybe better predict things. But imagine, so this took 6 years to get through because this isn't just about a camera sitting on top of your helmet. This is about making information accessible on the flight line in a protected way, putting a computer on the flight line that is safe, intrinsically safe to be present on the cart,
Hmm.
which is now you're not just collecting the sensor data, we are collecting video maintenance logs and audio.
Hmm.
That is the entirety of what we call a work order, which
Hmm.
is you're able to ingest the data as it comes off the aircraft in a as is state, raw data coming from the sensor saying this is what the engine is reading. But now we're able to go in and see from a non-deterministic way what was the quality and condition of the part as inspected, when it was inspected, and then you're able to take the audio around that to say here's what's the knowledge base around that, so you're able to get more of a holistic history in order to now create true predictive maintenance because you have a more well-rounded definition of metadata to go into
Sure.
that model. And so we're
Sure.
enhancing predictive, what the Air Force has been doing on the predictive maintenance side, in many different ways, just by different modalities that we're collecting.
Yeah, and well, some of these modern planes are incredibly complicated. You talk about like an A-10 Warthog, it's very different from an F-35. I mean, there are so many different information systems on these planes now, and that's why, as I understand it, some of them are not combat ready. They're not ready because there are so many I's to dot and T's to cross, basically. But what you're telling me is that MetroStar is actively working to build out the entire workflow around maintenance and to capture all this data, not just the machine data from the sensors, but the visual data from the cameras and the audio data from the engineers, the maintainers who are on the front lines, and take that holistic picture. And now you have a much better playbook for fixing future planes and also for preventing things from happening in planes, right?
Yeah, putting all that together, this is really our iPhone moment, right? Which is before it was, I have a device that plays music. And now what the iPhone did is gave them a platform
Hmm.
where, yes, I can listen to music, I can call somebody, I can check my wallet, I can have photos, I can have maps, I can have email. With this, it's before I have tools that let me communicate with somebody in the tank via knocking on the outside of the tank or drawing.
Right.
We're taking a generational leap to
Wow.
where now I have a platform because of the video, because of the communications, and because of the technology on the cart. It's not just hardware.
Hmm.
These are enabling communications, trends, capturing historical data, trends, connects remote uh, remote connections quickly. I can call an engineer in Kadena Air Force Base who might be the only expert that knows how to fix this problem.
Wow.
And
Right.
instead of flying them out from
Right.
Kadena over to somewhere around
That's
the
funny.
world, it's a phone call.
Right.
So that's what this is why we're so excited about it, is because this is something that is taking not just one generation is, okay, you now have a video, right? And you can record it and you have audio and you can talk. That's one generation leap. We're taking two generational leaps at once here because now we're putting AI next to the maintainer to say, let's not just observe how you do the work, let's augment it. Let's help you do it smarter and faster.
That's interesting. And talk about a really cool use case for large language models. They are very good at consuming large amounts of text. It can't be too big, it has to fit inside of a context window, but large amounts of very technical text, the kind you would get in a manual. And then now you have a natural language interface to ask it questions. Hey, this is the part. What are the things that can go wrong? And it can hit that whole or series of manuals and come back and say, hey, it might be this, it might be this, it might be that. Whereas in the old world, you would need that one person who knows all that stuff, and that person may not even be working anymore in the field. So, to your point, you're adding this corpus of knowledge of whatever you can feed into this model to the real world evaluation and the human instinct and the human senses that apply to the situation. You're bringing a whole world of opportunity to this particular problem, right?
Yeah, and shout out to the 100th MXG out there at Mildenhall Air Force Base. That's our first deployment of this. And we see two problems there with what you just said. One is manning. Manpower is not getting it is not an easy problem to solve for the Air Force. And then two is what we call training, time to competency. Uh, how can we actually leverage the LLMs, put constraints on them, guardrails in place that allows them, a two-person team, to quickly go in, understand exactly what they're working on and work on it in the right and correct ways, so that one, you can limit the teams that need to go out to a specific aircraft because you can now share that video and the work being done, knowing that it's in alignment with that tech order without carrying any extra equipment with them. And then two, time to competency. You only go into a fuel tank once, twice a year, maybe, if you need to do it more often in order it's broken more often, maybe. But these maintainers may not fully understand the fuel tank that they're about to go into because it's a different aircraft, and they're
Wow.
just there to help because
Right.
their competency is around fixing a fuel tank, not specific platforms that the fuel tank is located on sometimes. And so
Hmm.
what we're able to do is recall that information from the last time somebody was in the tank. Here's what that tank looks like. Here's the tech order. Here's the work manual. Here's the
Wow.
specific way you get the job done. Here's the tools
Right.
that you need to take out to the plane so you don't have to do 8 trips back and forth to find the right tool.
Sure.
And now the competency with a limited labor force that is how you drive efficiency and sustainability into limited resources that we already have.
Hmm. Well, the efficiency, I'm thinking about the little devices that you can use these days. When you go to the mechanic, he can just plug this thing into your car and read what the computer is saying. I mean, that's a huge gain over the old world way of doing it, which was just, okay, maybe it's this, maybe it's that manually. But you're talking about being able to do that for highly diverse fleets of machines there are all kinds of different variations on them. And to your point, someone on the job may not have seen this kind of machine before, but now through this network that you have through MetroStar, you can tap into this body of knowledge of understanding that includes not just the manuals through like a large language model, for example, but the actual human conversations about the last time this encounter or this problem was encountered, right?
That's right. And that's recall. Our ability to, during the maintenance process, there is planned maintenance and unplanned maintenance.
Hmm.
Unscheduled maintenance, unplanned maintenance is one of the big drivers of downtime because you've got to go triage the information. You've got to go inspect the aircraft. You've got to go figure out what's wrong with the aircraft. You've got to talk to the maintainers or the OEMs about
Hmm.
what's wrong. And then you've got to order the part and then you got to fix it. That is a
Hmm.
whole lot of things that are non-deterministic, and in some ways unpredictable that we're now taking what you said and we're shrinking that timeline so much more because of the ways that we are bringing that information together for those maintainers.
Yeah, that's really cool. And so the other cool thing you're doing here is you're really helping the maintainers know that they're on the right track. I mean, this is the problem. It's like when you lose your keys and you can't find your keys and you don't even know if they're in your house. It's the most frustrating thing in the world, right? Like if maybe you were out at a friend's house or something. If you don't even know that they're in the house, it's very demoralizing looking all around the house to find this darn thing. So what you're doing is you're really expediting the process and keeping the morale high of the maintainers because now they know they're at least on the right track. And typically, when you're troubleshooting, that's the most important thing. Am I even moving in the right direction as I try to solve this problem? Knowing that, I think, is huge for morale, right?
Huge for morale. You're saving on incidents. Imagine fixing the wrong thing because the wrong picture was drawn.
Right.
So the time saved based on incidents. Next is remote technical assistance. Because the person who has the most expertise may not be local,
Hmm.
you're now reducing the rework needed to go into the tank, take time into the tank, which is life, right? Safety.
Right.
And that you now have the person who has the expertise working with you right then and there. And you're limiting the time in tank. You're reducing turnaround time of the aircraft because instead of it, hey, call me back. I got to jump into the plane. I got
Right.
to jump into the plane for
Right.
2 hours. I'll call you 4 hours from now when I figure out what the heck you were talking about. And
Wow.
then, and then one of the processes is how long does it take to get information to that engineer before
Yeah.
it's up to about 6 hours because you got to empty the tank. You got to empty the tank and then you've got to go take a picture and then send that to the engineer. It's time.
Talking to the team now at MetroStar about Iris, this very cool technology. We're talking about applied AI, and I think it's fascinating. I've been tracking this space for a long, long time. In fact, when I was first working with the Data Warehousing Institute, I guess as a an employee back in 2005, I interviewed a guy who was all about predictive maintenance on aircraft. And he was talking about how they use data mining to track and to see and get leading indicators for when there are going to be problems. So when this part starts to rattle, if you change it quickly, that part will not be compromised. And that kind of thing has been around for a while. But you guys are pretty advanced. And of course, a huge part of this is the data side of it. So I've got Wilson Rodden on with MetroStar Principal Applied AI and Product Guy. So, Wilson, where do you get the data? What does the data look like? How do you vet the data, source the data? Tell us all about that fun stuff.
Absolutely, Eric. So, to give you the high level first, this data is generated every time maintenance activities are performed within the fuel tank currently, as well as anytime there's documentation written up around those maintenance tasks, things of that nature. And we've even begun to collaborate. One of the things that I believe Hannah's probably going to go into here in a bit is our effort to collaborate with maintainers themselves as we generate these knowledge bases, right?
Hmm.
Because a lot of the times this information is being siloed off in individual minds. And so the real goal of Iris is to be able to create generational knowledge between maintainers, supervisors, engineers, building this collaborative environment where we're able to extract data from areas that were, I guess, black boxes before.
Hmm. Well, this is really interesting stuff because what you're talking about is being able to capture what used to be referred to as head knowledge of the individuals. And so that used to be done in a very manual way, have someone write down what they're doing. I mean, I guess sometimes you could record it into a device of some kind, but historically it was a very manual process, and you would write a manual and refer to the manual. But what you guys envisioned is, look, if we have the technology to enable a real-time interaction with this knowledge base built from the experiences of all their other maintainers and team members and so forth, that's going to greatly expedite any mission that someone engages on, right?
Absolutely. And when you think about what's being recorded and how to perform a maintenance task, right? It's extremely difficult to ensure that everything that someone needs to know makes it into just a single form of documentation, right? If you've ever taken an effective communications class or something like that, a lot of the times they'll do that exercise where it's tell me how to make a peanut butter and jelly sandwich, right?
Right.
Yeah, and it's all about interpretation of those instructions and specificity. So one of the goals that we have with Iris is to ensure that information that typically doesn't make it into the task orders or the TOs is able to be preserved somewhere and served up to those maintainers so that they don't get to find out what size wrench they were supposed to bring into the tank when they're finally reaching their bolt.
Wow. Ouch. Yeah, that can be very unpleasant. So the data itself, is it stored in a multiple number of forms? And because there is verbal information, there's written information, and then how do you actually store that data? Is there like a particular kind of database that you're using? Is there a graph? Is it a knowledge graph? And if you could get into the weeds a bit about how it's persisted and then how it's accessed.
Sure. So as you mentioned, this is a multimodal problem. That's something that Jesse will get into here in a moment. And I can actually pass it over to him in a moment. But depending on the data type, right? There are different, more efficient ways to store, documentation or manuals versus videos themselves. Where at the end of the day, one of the things that we'll get into here is we're using not just even applied AI, right? When in AI in kind of the buzzwordy sense, where it's Gen AI, text generation, things like that. Yes, we do have that component, but we're also using advanced computer vision techniques. We're using traditional machine learning methods. And at the end of the day, each of those query data just a little bit differently. And so to drive efficiency, we've got right now a few different approaches in mind. So I can bring Jesse in here to talk a little bit more around how it was that we got the initial data structure up and running.
Yeah, sure. Jesse, go ahead.
Yeah, to Wilson's point, lots of different types of data, modalities of data. So you can think of videos, MP4 files, audio files, and then PDFs that may or may not be your ideal state of a PDF that contain technical order information, kind of process guidelines on how to complete certain maintenance. So yeah, they're all read in different ways, stored in different ways. But ultimately, we're doing a lot of business logic and processing at ingestion point of this data so that it ends up in one kind of common playing field and can provide context and inform various models that the end users are interacting with.
That's pretty interesting. So you've got multiple models too underneath the covers, right? And maybe I'll throw it back over to Wilson. And this is one of the cool things about AI is that it's, some people say, oh, we need to buy the AI. Like, okay, well, which one? There are lots of different ones, right? And I think this is going to be a standard going forward, that there will be many different models in production at organizations doing specific things. And you, Wilson, you kind of mentioned large visual models, right, as opposed to large language models. This is a real push these days, and it was fun. I actually had a guy from Ford Motor Company on the show, gosh, I guess about 8 or 9 years ago, when a lot of this stuff was really started to take off. And he said they're very, very excited. This is back then, because what you would do is you'd hold your phone, your camera over the device, and it would tell you, oh, this is this part, this is that part. That's exactly what we're talking about here, right? Is using a large visual model to say, oh, okay, this is an X kind of plate, you need that kind of bolt, and that information is being dynamically served through your information systems, right, Wilson?
Absolutely. And so to give a little more context around when we're talking about these vision models and the distinct challenges in supporting maintenance processes with these vision models, if you think about traditional computer vision in the sense of, object detectors, things of that nature, they typically don't care about time at all. So that would be if you're parsing something like a technical order or a manual on a specific repair order. Those are static images, right? There's nothing, page one, the text informs page two typically, so context matters in that regard, but a picture on page one isn't necessarily related to the picture on page two.
Hmm.
Whereas when we're dealing with video, the way that we phrase this in the machine learning world is temporal awareness, right? So we know that time is a forward moving context, right? So as information is presented to you frame by frame, we know that things in the past and future also matter for that. So one of the real challenges is figuring out how do we make these models that not all of them are temporally aware, but how do we make it so that they are more video friendly, more so than just individual image friendly. And
Hmm.
that's a particularly fun challenge.
Well, I was going to say that's something we could dig into here a bit. So, what you're referring to is the fact that a photograph of a part is a static image. But when you're walking someone through a process to fix something in a video, well, that's not a static image. That's a whole series of images. And there is the time dimension which comes into play here. It doesn't mean that you have to complete the task in that amount of time necessarily. But the point is, time is a dimension here as opposed to with a static image. And I remember interviewing a guy whose company is actually delivering the data into Meta's Llama 2, Llama 3, Llama 4 engines. So they're the data orchestration engine, basically. And he was joking. He said, look, all the text in the world can be consumed by GPUs in a day. But video is a much different story because with video, now you're capturing everything. You're capturing the audio, you're capturing all the pixel changes and everything, and being able to identify an object in video is therefore a little bit more challenging than identifying it just in a static shot, right, Wilson?
Absolutely. I mean, when you're dealing with video, the same object can look very different depending on the direction that it's facing, depending on lighting conditions, obfuscation, how much of it is occluded from frame, things like that.
Mm-hmm. Mm-hmm.
Um, So I'd love to bring Jesse in here to talk a little bit about some of the strategies that we're using to bring that temporal modality into play.
Yeah, go ahead, Jesse.
Yeah. So, yeah, thinking about, video at its core, right? It's progressing through time. Things are happening in a particular sequence. When you look at traditional methods for even something as simple as searching information within that video, you might try to enrich or extract information from individual frames. That individual frame is not going to give you information on what happened before or after that frame. So there are models out there, and we're working on techniques right now and have implemented a few techniques on how to provide context to one, the user, and inform the search and inform large language models on context about what is happening around the frame. So there's a few techniques. I'm not sure how deep in the weeds we want to get, but there's a few techniques on how to do that.
Yeah,
But
I'd
yeah,
I'd be curious because you can, so just to explain it to the audience out there, I often use the example of Shazam for a modern implementation of AI. And it's fascinating. All the kids know they can just all the songs on the radio, they hit Shazam, it goes, "Oh, this is the song," because it has a signature, it's watching for a certain pattern. They've obviously assimilated this song into their either a vector store, I'm not exactly sure how they do it, but there's a signature to it, and you can get the same thing with the motion of something.